Hello everyone. So as in the last lecture means in the lecture 4th part A, as we have seen the three transformations. Transformation number 1, if you see the transformation number 1, let me take a quick revision that in transformation 1 what we have learned, that is y is equal to f of x plus a or f of x minus a. It means the graph is shifting along with x-axis left or right according to as per minus a and plus a. Now y equal to a plus fx or a minus fx. That means this is the transformation A. The graph is shifting along with y-axis. And third transformation what we have already discussed, that is y is equal to f of minus x. Means domain is if negative, then the graph is shift along with y-axis. It means it is just you can say it is a mirror image with respect to in y-axis, with respect to y-axis, as here y is equal to f of minus x. Now if you see, so from this in this lecture we will go for transformation 4, as 3 transformation we have already yet completed. Now let's start transformation 4. Fine. So in transformation 4 what we will learn, this one, how to plot the graph of y equal to minus f of x. Let's see, y equal to minus f of x. So let's say if fx is here, you can see if fx is above x-axis, then it comes in negative part, and if it is in negative, then it comes in positive. Means to plot y equal to minus fx, draw y equal to fx first and then take a mirror image of y equal to fx in x-axis. It's okay. So let's take a look of this any function. So if you say this is x-axis and this what I call y-axis, and here let's say this is y equal to fx, this part, this is y equal to fx graph. So where the y equal to, now we are interested to find y equal to f of minus x, y equal to minus f of x, right? So for minus f of x, the negative region comes in positive towards and positive region comes in negative. Means all the part of y which is holding positive, it comes in negative. It means it is with respect to, you have to take the image with respect to x-axis. So the positive part of the image is like this way, okay, and the negative part of the image is you say like this way, like this. So if you join this blue part, this part, then this is blue part is the graph of y equal to minus f of x. So you see here that this portion of the graph has the image here in this portion, which is the part of y equal to minus f of x. And if you see this portion here, then this portion has the image over here. This portion is the image in this portion. It's okay. So this is the part of the graph. Now if you erase this white portion, then this graph becomes y equal to minus f of x. Fine. So let's take some example over here. In the example what we see, let's take illustration. Sketch the graph of the following function. First part, x square y equal to 1, and second part we will go for y equal to ln of 1 by x. So let's say we are interested to find the graph of x square y equal to 1. So what it means, y let me write down over here, x square y equal to 1, correct? So let's take example, x square y equal to 1. Where is this? Here there is x square y equal to 1. Let's see one more example, x square y equal to minus 1. Okay, fine. So let's say x square y equal to minus 1. So what our planning is, so we will plan like this way, y equal to minus 1 by x square, correct? So how to plan this? So in step 1, what we will do, in step 1, first of all, we'll go for y equal to 1 by x square, graph it. And in step 2, what we will do, our planning is, then go for y equal to minus 1 by x square by using the concept of drawing y equal to minus fx. So let's start. So this is the step 2, this is step 2 part, and this is the step 1 part, you say. This is the step 1 part, this part. So first of all, we will go for step 1, that is y equal to 1 by x square. So let's draw y equal to 1 by x square graph. So how will draw? First of all, draw the graph of x, graph line x axis and y axis. Okay. So let's say y equal to 1. As you know, there is an even power on x variable. So graph is symmetric about y axis. So y equal to 1 by x square, this is a rectangular hyperbola structure. So you can graph like this way. So I'm going to draw with the red color of y equal to 1 by x square. This is a rectangular hyperbola type. But here it is, its part comes in its shear first and second quadrant, as it is with the image with respect to y-axis. As you know, let's say this is y-axis, this part. Now if we say y equal to minus 1 by x square, so how you will go for y equal to minus 1 by x square? So let me draw the graph. You have to take the mirror image with respect to x-axis like this and like this. Mean the part of this graph, the image here, there is the image, and in the part here in the second quadrant, what is the image? Image goes in fourth quadrant. So what we share in third and fourth quadrant, that is the part of in the fourth quadrant, what we share in third and fourth quadrant, that is the graph of y equal to minus 1 by x square. So this is the graph of y equal to minus 1 by x square. Let me write down y equal to minus 1 by x square. Fine. So let's see over here illustration. X square y equal to minus 1, and here that is y x, we wrote here y equal to minus 1 by x square. So fx to minus f of x, how we'll go for this? So let's draw over here. This is the graph of y equal to 1 by x square, as it is sharing first and second quadrant. And after this we have drawn the mirror image about x-axis. So we got y equal to minus 1 by x square. Here this is y equal to minus 1 by x square, and here this is y equal to 1 by x square. So taking the mirror image here, we get this part. So we have to draw minus f of x, what we have learned how to draw minus fx concept. Okay, anyhow. So let's take one more example, ln of 1 by x. So how to draw this ln of 1 by x? Let's see. So in case of ln of 1 by x, ln of, first write down what we have, what is the objective over here. Y equal to, we have to plot ln of 1 by x. So for y equal to ln of 1 by x, some student can write simply minus ln x. So for y equal to minus ln x, better just draw y equal to ln x and then go for minus ln x. This is our planning. So let's draw y equal to ln x here. This is y equal to ln x, right? This we have drawn y equal to ln x. Now to plan y equal to minus ln x, how to draw y equal to minus ln x? Let's say y equal to minus ln x here. So we have to take the mirror image with respect to x-axis, and here this is y-axis. So the portion which is in positive region that comes in negative region like this, and the portion which is in negative region that comes like this way. Means it is just like log x. We are drawing here log x base a, and a is fractional base. Here a is positive base, as this is the graph of ln x and this is ln of 1 by x. So finally this is the graph of y equal to ln of 1 by x, and you know this is the graph of y equal to ln x. Okay, fine. Let's see over here. This is the graph here, y equal to ln x. You know, this is the graph of y equal to ln x. Let's see this portion, y equal to ln x. And after taking mirror image with respect to x-axis, the negative portion goes in positive region. The negative portion goes over here. You see here, this negative portion. This negative portion goes. This negative portion goes here in positive region, right? This positive region. And here, what we see, what is the region over here in positive? That is comes in negative region. That comes in negative region. What we have learned in previous graph. So let's see this part. Okay. So hence we can say this is the graph of y equal to ln of 1 by x graph. So now once again we are taking the mirror image with respect to about y-axis, x-axis. So here, whenever there is a negative sign in range, then you have to go with along with y-axis, and negative sign in domain, then you have to take a mirror image along x-axis, as we have learned in transformation 3. So this was fourth transformation. So let's take another transformation, that what we call fifth transformation. In the fifth transformation, we have to learn about y equal to f of mod x, how to draw the graph of f of mod x. Let's understand what is f of mod x graph. So if we draw y equal to fx, step 1 you have to draw y equal to fx, and then draw the graph and take the mirror image. Before taking mirror image, you have to remove the portion where it is in negative region in left half, and the other after that take the mirror image of the portion graph in the right half in the y-axis. Also include the right portion of the graph on y equal to fx. What it mean? Let's we take here to understand. Come here to understand on the board. So for y equal to, now we are interested to draw the graph of y equal to f of mod x. So let's say this is y equal to fx. This is x-axis, and this what I call y-axis. Let's say this portion is y equal to fx. Okay, fine. This is y equal to fx. Then what we are saying, that you have to remove this left portion. What portion? We have to remove this left portion. We have to remove this portion, this left portion. Left portion, remove it, erase it later on. And then what we have to do, you have to take the mirror image with respect to y-axis. You have to take the mirror image with respect to y-axis. Now put the mirror on y-axis. What we have to go here? We have to put the mirror image with respect to y-axis like this. Okay. So whatever the graph portion here, this is white portion, you have to take the mirror image with respect to like this way, this portion. And include this white portion also. Include this later on white portion also. So let me draw down red highlighter over here. So this portion as well, this portion is the part of the graph. This portion. So this red highlighted portion is the part of the graph. And later on what we have to do, we have to erase this portion, blue portion. So this will be the graph of y equal to f of mod x. This is the graph of y equal to let me erase this, and here this is the graph of y equal to f of mod x portion. So let's take some example over here. Suppose we are interested to find y equal to, let's take some illustration is there, y equal to mod x plus 1. Now we are interested to draw the graph of y equal to 1 upon mod x plus 1. And second question, we have to go for y equal to x square minus 2 mod x plus 3. There are 3 different types of graphs. So let's go one by one. Y equal to 1 upon x plus 1. So 1 upon mod x plus 1. Let's see over here. So we will plan like this way. The question was y equal to 1 upon mod x plus 1. Let's say, let me note down first. Y equal to okay, y equal to 1 upon okay, mod x plus 1. So what's the planning over here? What is the planning over here? We will plan like this way, that in step 1 what we can do over here. In step 1 we can do like this way, y equal to, as like y equal to 1 upon x, we will draw the graph of y equal to 1 upon x first. Then by simply shifting, as in transformation 1 we have discussed, y equal to 1 upon x plus 1, number 2 step. And in number 3 step, what we will go like this way. In number 3 step, we can go like this way, that we have to graph f of mod x, as fx is given. So from fx to we will make the transformation of f of mod x type structure. So in this way, we will get like this way, y equal to 1 upon, wherever there is x, you have to make a mod x. So mod x plus 1. So how will tackle? So, you know, y equal to 1 by x is a rectangular hyperbola. So, for this first step, you have to go for y equal to 1 by x. And then in the second step, you have to shift along with x-axis. Now, while shifting along with x-axis, as instead of x, that is x plus 1. So, the graph will shift leftward or rightward. Imagine this. Okay. So, finally, what we conclude, that as x plus 1 is there, so the graph will shift backward, means leftwards along x-axis. Okay, and suppose instead of x plus 1, if it is x minus 1, then graph shift rightwards. So here in this case, 1 upon x plus 1 is there, so graph will shift leftwards. And later on we will take the mirror image with respect to x-axis, y-axis, as f of mod x. So let's start. So we will go for this one, y equal to 1 upon mod x plus 1. Let's say y equal to 1 by x first. This is the portion of y equal to 1 upon x. Fine. As you know, this is y-axis and here this one is x-axis. So to shift this graph, what we go like this way. Now we will go for y equal to 1 upon x plus 1. How to draw this graph? As you know, this is the portion here. Now this is minus 1. So graph will go like this way. Graph will go like this way, and here graph will go like this way. This is y equal to 1 upon x plus 1. Fine. And now we are interested to draw the graph of y equal to let's say take this, y equal to 1 upon mod x plus 1. So what we will do? So as for this mod of fx, f of mod x, what we do, the graph which is in negative region, we have to ignore it. Which part we have to ignore? Let's see. We will highlight which part we will ignore, or you can say we won't go for the portion, we will highlight in this color. Okay, so this portion and this portion which is the graph of y equal to 1 upon mod x plus 1, we have to remove this. Means we have to erase this, and we have to consider only the part which is this one, a red portion. Red highlighted portion will be considered as the graph. So what the graph will be here? The mirror image with respect to y-axis. The mirror image with respect to y-axis, what we have to do here. Now take the mirror image with respect to y-axis. So the graph goes like this way. Okay. This part, right? So let me highlight this once again, and the portion which is over here also, this portion and this one. So red highlighted portion is the graph of f of mod x, means 1 upon mod x plus 1. This portion, 1 upon mod x plus 1. So let's see. So in this graph, what we see over here, that this is the graph of 1 upon mod x, y equal to 1 upon mod x, and then after what we see over here, 1 upon x plus 1, y equal to, here we draw as y equal to 1 upon x plus 1. So here this is the graph y equal to 1 upon x plus 1, y equal to 1 upon x plus 1, and this is the graph what we finally get f of, this is an example of f of mod x as we have done, and finally we got the result y equal to 1 upon mod x plus 1 plus 1. Okay, fine. So finally this part of the graph is to be considered, this graph and this graph. This is the graph, and which goes up to x-axis, negative x region. Now let's say y equal to x square minus 2x plus 3. So we have to go for this part of the graph, y equal to x square minus 2 mod x plus 3. Let's see how to draw. So what we see over here. So to draw the graph of here, x square minus 2 mod x plus 3, y equal to x square minus 2 mod x plus 3. Here the planning is there that, as you know, that is x square and mod x whole square, that is the same thing. So for x square, some student can also write over here like this way, that is y equal to what we see over here, that is y for x square, what do we say? So you know that is x square or mod x whole square or x square mod x or x square mod of x square. These all are same thing, right? So for better, just instead of x square, one can write mod x whole square minus 2 mod x plus 3. So what is the planning over here? We make the function as quadratic function, that is x square minus 2x plus 3, and later on first of all plot this function and then plot for f of mod x. So let's try. So our target to find x square minus 2x plus 3. So let's see. Y equal to x square minus 2x plus 3. So we will focus on x square minus 2x plus 3. As you see in this quadratic expression, what is that? Is this factor can be split in two linear factors? So not possible. Why so? Because if you check the discriminant over here, if you check its discriminant, then discriminant is equal to, you know, b square, that is 4 minus 4ac, that is 12, and that is somehow negative 8. So that is negative. It means it's not possible, right? So let's see over here that its discriminant is negative. So as discriminant is negative and its coefficient of x square, you know, this is positive. So graph is above x-axis. So if you draw over here, then that is means it hasn't any real root, distinct also not that. So it consists some imaginary roots. So it doesn't intersect on x-axis. So if you plot the graph over here, x square minus 2x plus 3, the graph goes like this way. This is x-axis, this is y-axis, and if you see this here, the turning point is, if you see this here turning point, let's solve its turning point. That is minus b by 2a, that is x equal to 1. X equal to 1 is the turning point, you know, that is minus b by 2a, that is means negative 2 upon 2. So that is 1. So at x equal to 1, you see over here, so at x equal to 1 it consists some minima point because coefficient of x square is positive, concavity is upward. If you put x equal to 1 over here, then you find that is 4 minus 2, that is 2. So let's say 1 to this point. At this point it consists minimum point 1 comma 2 point, and at 0 it passes through 3. So if we graph over here this portion like this, graph goes like this way. So on y-axis it passes through 0 comma 3. This is the portion of x square minus 2x plus 3. This is y-axis. Now for in the negative region, here you have to discard negative region. So let me shade yellow in color, which I have to discard. This portion you have to discard only this much, right? And later on we have to cover up this which is in positive region and put the mirror on y-axis. So let's we put a mirror on y-axis over here. So put the mirror on y-axis, and now the part of this image here, and you have to also include this white portion on which we are making hovering over the red dots over here. So whatever the portion hovering with red dots, you have to take the mirror image and also include this portion also. So let's say, and this is the where the dip is there, you know, this is the point 1 comma 2, 1 comma 2 you can say is the coordinate. So here the coordinate will become minus 1 comma 2. So that is minus 1 comma 2, and this point is coming from 0 comma 3, you know, 0 comma 3. From 0 comma 3 point goes like this way, and this is the graph. So finally the graph is like this way. If we overline here the graph with this pink region, this part of the graph is to be considered. This part of the graph is to be considered. This is the final graph of y equal to, you know, this is the graph here, that what we call here y equal to x square minus 2 mod x plus 3. This is the portion of graph. So this is the final region. Let's see over here. So you can see over here this one in this slide what we have done here. Here the portion is, that is x square minus 2x plus 3. First of all you have to draw. This portion is x square minus 2x plus 3. Let me consider this. So let's see, x square minus 2x plus 3. This portion is x square minus 2x plus 3 part. This portion. And here finally we get the graph of f of mod x. So we find shape W shaped graph, that is at x equal to 1 and minus 1. This point is, you know, that is the minimum point, and this point is here. This is 1 comma 2 you can say, as we have marked over that was 1 comma 2, and here that is minus 1 comma 2 portion, this point. There are the two minimas you can say, and one maxima at x equal to 0. This minus 1 and plus 1, both of them are local minima, you can say. Local minima. Which one? Minus 1 and plus 1. And the local minimum value, that is 2. And x equal to 0 is the local maxima, you can say. And local maximum value is 3. At x equal to 0, the value is 3. So this is finally, although here if you see, global minimum is there 2 and global maximum does not exist. Later on we will go for maxima minima chapter, so we will get the concept clear over there. Okay, so let's go for another transformation. Let's see. So for another transformation, that is 6th number transformation. As we in 5th transformation, what we have discussed, f of mod x. Now in 6th transformation we will discuss mod of fx. So despite of 5th transformation, here we have to put the mirror on x-axis, as in 5th transformation for f of mod x we kept the mirror on y-axis. So in that portion where we have to reject the portion in the negative region, here with respect to x in negative region, we have to reject the portion, and we have to consider the positive region portion and the new image portion also. So what is transformation 6? Let's dive in. Y equal to mod fx. To plot mod fx, draw the curve y equal to fx, then take the mirror image of the lower portion of the curve, the curve below x-axis, in the x-axis, and reject the lower part or flip lower part into the upper. Also include the upper portion of the curve y equal to fx. So let's take some example over here. So here are the two illustrations we have to do: x square minus 2x minus 3 mod, and then y equal to mod of ln x. Mod of ln x. So x square minus 2x minus 3. Let's analyze this in detail. So let's see first. That is x square minus 2x minus 3 entire mod. Before this, we have to retrace the graph of f of mod x. Let's see. For f of mod x, y equal to mod of fx. Mod fx, what you have to do? What the graph is over here, this is y-axis, you know. This is the y-axis. And let's say this portion is the graph of y equal to fx. This is, let's say, y equal to fx. Now we are interested to find the graph of y equal to mod of fx. Mod of fx. So let me note down in blue color so that we will plot the graph. And here what we have to do, put the mirror image, mirror on x-axis. So x-axis has be mirror line. So take the graph over here, mirror image of this x with respect to x-axis, and also the portion which is included. This portion is also included. So this entire, the blue line, blue overline portion, and the blue line is the graph of mod of fx. This is the graph of mod of fx. So let's do one illustration over there. That is x square minus 2x minus 3 mod. Let's see. Y equal to x square minus 2x minus 3 or plus 3. Let's see. Minus 3, fine. So y equal to x square minus 2x minus 3. Okay, fine. So that is minus 3. Minus 3. So first of all, as this is a quadratic expression, to analyze this, as you know, we can factorize also. Here the factors are x equal to x plus 1 into x minus 3 1. So x minus 3, correct. Let's check. Yes. So finally what we do over here, there are the two roots, one is -1 and other is +3. So let's draw the graph over here first. This one, this is somewhere -1 and somewhere here that is 3. So graph goes like this way. At x equal to 0, if you see, that is the result is -3. So we need more space over this. So let's see over here for this y equal to x square minus 2x minus 3. Okay. So for this is x-axis, this is what you call y-axis, this is somewhere here -1, this is somewhere here 3, and when you put here 0, then it is also -3. So graph goes like this way. Some point is there where the minimum point is there. You see at x equal to 1, although it comes on 0 to 3, right? So when you draw the graph over here, putting the mirror line on x-axis, then you know this is the graph. Here you put the mirror with respect to x-axis, so the graph comes like this way. This is the point, as this is 0, -3. So here that is 3 portion, and here somewhere else point at x equal to 1, and this portion will be also included over here. So this is the graph here, like this. Okay, fine. So this is the graph of x square minus y equal to x square minus 2x minus 3 entire mod. Okay, let's take one more example. That is another illustration, y equal to mod of ln x. Then later on we'll discuss in detail. So we have to draw y equal to mod of ln x. First of all, what we have to go? We have to go for y equal to ln x. What is y equal to ln x? That is simply the graph comes like this way. Okay, this is 1, 0. At 1, this is y-axis. This what you call x-axis. At graph approaches towards -infinity towards negative y-axis. Okay, fine. At x equal to as x tends to 0 from right limit. So if you take the mirror image with respect to here, for y equal to mod ln x, entire negative region graph comes like this. Okay, so the graph comes like this way, and the portion also which is existing here in positive region, this will be also exist. This is also included part, and this portion. So this line will become y equal to mod of ln x. Let's have a brief look. So you see y equal to, that is x square minus 2x minus 3. In this first portion of the graph, what we have done here, that is a simple quadratic expression which is passing through -1, 0 and 3, 0. At 0, -3, it crosses from y-axis, as y-intercept is -3 in this graph. And now flip the lower part. You have to flip this lower part here, which is in negative region. So it comes here in opposite region, and as well the graph is above, which will be also included. So this is the graph of x square minus 2x minus 3 mod. Let's check another graph, y equal to mod ln x. So for y equal to mod ln x, you see here what we have done. The graph y equal to ln x is simply over here, and see over here, this is the graph y equal to ln x, and here for y equal to mod ln x, once again we'll put the mirror, and this portion we will take the mirror image over here, and also the portion which is existing in positive, that is the graph of y equal to mod of ln x. We have to flip the lower part in upper portion. This is the graph of y equal to mod of ln x. Okay, so let's go for next transformation. Transformation number 7. In transformation 7, we will discuss mod y equal to fx. Despite of previous transformation, what we have discussed in transformation 6, we have discussed that mod is on fx. Now mod is on y, not on fx. Fx is as it is. So for this, what we have to do, to plot mod y equal to fx, draw y equal to fx and then remove the lower portion of the curve, part of the curve below x-axis, it means. Then take the mirror image of upper portion, part of the curve above x-axis in the x-axis. Also include the upper portion of the curve y equal to fx. Let's see what we will do over here. As for mod y equal to fx, mod y equal to fx, what we will do? In step 1, what we have to do? We have to draw the portion of, first of all, note down this is x-axis and this what you call y-axis. Now, first before this, to draw mod y equal to fx, we have to check where this fx is going on, like this way, this like this and like this and like this. Suppose y equal to fx is over here. So we haven't to consider as the portion of the fx which is in negative region, with respect negative region means in below x-axis. So in the below x-axis portion, we have to discard. We have to discard this below x-axis portion. These portion we haven't to consider. We haven't to consider this portion. We have to consider the portion only which is in positive region. So let me overline this in the positive region with blue line. So we have to consider and this, and then later on what we have to do? We have to take the mirror image of this blue portion with respect to x-axis. So I'll explain later on. First of all, let me take the mirror image here with respect to x-axis here, and the graph comes like this way. This is the portion of this portion, and for this portion we have to go like this way. So finally the required graph is this portion. So I am highlighting with red color. This is which is the mirror image and the already existing graph. This part we have to include. We have to include this part, and then we have to include which is the mirror image of this part. So this is the graph of mod y equal to fx. This is the graph of mod y equal to fx here. Okay, fine. So let's take some example to understand this. As you know, draw the graph of the curve mod y equal to x minus 1 and x minus 2. What we say here, mod y equal to x, and then after second illustration we have to focus for mod y equal to sin x. So let's discuss one by one. Once again, let me note down over here. So for as y equal to, let's see, mod y equal to, we are interested to graph, it is sin x. So for this you have to draw the graph of y equal to sin x. So for mod y equal to sin x, I am planning to draw the graph of y equal to sin x first. Y equal to sin x. How to draw the graph of y equal to sin x? Like this. This is the graph of y equal to sin x, And for mod y equal to sin x, as this is y axis, this x axis. This portion is sin x. And for mod y equal to sin x, you have to consider the mirror image here, this portion, and then this portion. This is the portion here, and let me reject portion. These portion will be rejected. This portion will be rejected, and we have to flip this upper part in lower, and this also comes to be considered. These part also to be considered in the positive region, in the positive region, and in the positive region. These are the graph of mod y equal to sin x. Okay. Anyhow, so transformation 8. Transformation 8 is very important for IIT point of view. This is transformation of GI function. So GI is a very favorite topic of IIT JEE. So let's see y equal to how to transform GI of fx. For y equal to GI of fx, we have made here steps. So step 1 is draw y equal to fx. First of all, what do you have to do? Draw y equal to fx. Step 2, draw y equal to k horizontal line separated by unit distance till they intersects the graph where k belongs to integer. From the point of intersection of the above horizontal line with the graph of y equal to fx, draw a vertical line. Okay. Then step 4 is from each intersecting point, draw horizontal lines up to the nearest right vertical line, each that the horizontal line is always below the graph. Horizontal step down in step 4 is the graph of y equal to GI of fx. Let's redefine with the curve. So this is the curve, as here there is an illustration. So let me explain this first. What is y equal to GI of fx? As, let's see, for y equal to GI of fx, for y equal to GI of fx, let me note down the function y equal to fx first. Let this be x-axis, and here that is y-axis, and here that is y equal to fx. Y equal to fx. Okay. Now, for GI of fx, what we have done, if you see, then we have to mark the integer points on y-axis. You can say. So mark this integer point 1, 2, 3, 4, 5. Here 0, here -1, here -2, -3, and -4, and so on. And you just cross it. You crossed it, so that it intersects the line. Okay. And where these integer points marked and it intersects the curve, mark these points. This point, this point, this, this, and another this one, and this one. And now what you have to do, you have to put this, you have to drop this line vertical. So consider from anywhere, like this, like this, like this. Okay, okay. So from here, now here there is intersecting point, here there is intersecting point, and here. Now what we have to do, you have to join this with the graph. So let me use some another color. Let's use white color. Not white we have already used. So go for green color of GI of fx. So for GI of fx we are using this portion. So finally the green color graph will represent the GI of fx. So let's see. If you consider any of the vertical axis, so vertical line, which is the nearest dot that join this. This is the graph of GI of fx. Fine. This is the graph of GI of fx. This is the part of GI of fx. Okay. This one. And here. Okay, fine. So these green portions are the GI of fx portion. Fine. This is complete analogy. As draw y equal to fx, draw y equal to k horizontal lines separated by unit distance till they intersects the graph, what we have done with the red lines, and where k belongs to integer. Then find the point of intersection above horizontal lines with the curve y equal to fx, draw vertical line, and from each intersection points draw horizontal line up to the nearest right vertical line through the horizontal, that the horizontal line is always below the graph, by which we used green color over there. And horizontal steps in the step 4 is the graph of y equal to GI of fx. This is the graph of y equal to GI of fx graph. Okay, this type of portion what we have done over there. Okay, anyhow, so let's see illustration. The illustrative concept is y equal to, we have to plot the graph of y equal to GI of 2 sin x in 0 to 2 pi, and then we have to go for y equal to x by 2 GI. Two different graphs are there. So you see over here y equal to GI of 2 sin x between 0 to 2 pi. First of all, between 0 to 2 pi we have to draw the graph of y equal to 2 sin x. So y equal to 2 sin x, this part of graph, you see from 0, this is 2 sin x. So you know this portion, these portions are pi. This is pi portion, and this is 2 pi, and this is 0, and its amplitude is up to 2 and minus 2. Its range is minus 2 to plus 2 for y equal to 2 sin x. You know, for y equal to 2 sin x, you see y equal to 2 sin x if we use. So 2 sin x lies between minus 2 and plus 2, as you know. So the graph is spanned over y-axis on minus 2 to plus 2. Now between minus 2 to plus 2, as it is oscillating, so we have to recognize the points where y-axis, on y-axis the integers points are there. So we have to mark some integer points on y-axis. Let's see over here. At 1 and 2, at this portion is 1, you know, this portion is 1, 2, and like this. So here minus 1, minus 2, and draw the line parallel to x-axis where it cuts. So where it cuts, so one line, if you put over 1 over here, sin x when 2 sin x becomes 1, when 2 sin x becomes 1, when sin x becomes 1 by 2. So sin x becomes 1 by 2 at point pi by 6 and 5 pi by 6. So these points are pi by 6 and 5 pi by 6, where sin x attain 2 means 2 sin x attains 1, and 2 sin x when attains 2 means when sin x attains 1. So that is at pi by 2, right? Pi by 2. This is sin x attains 2 sin x, and 2 sin x attains minus 2 at, that is pi by 2, and you have to put 2 pi more over here, so that is 2 pi, so 3 pi by 2, that is minus 2. So this is the point that what we call 3 pi by 2, and here that is pi by 6, 5 pi by 6, and 7 pi by 6, 11 pi by 6. At 7 pi by 6 and 11 pi by 6, it attains once again minus 1 by 2. So when sin x attains minus 1 by 2, then it becomes minus 1 by 2 into 2, that is minus 1. So minus 1 is coming at 7 pi by 6 and 11 pi by 6, you see 7 pi by 6 and 11 pi by 6 here. Okay, fine. So these points are integer points which have already marked. So as we have marked over here, so these are the intersecting points. On these intersecting points, what we have to do, we have to plot the vertical lines over previous. So previous line vertically you have to draw like this, and what we have used over the green color, so we have to draw like this the graph, and but here also like this the graph, right? And similarly here also, that the same portion, that is some bit portion is there, little bit portion we have to use like this way, and from here also we have to use this little portion, and then after we have to use this portion. If you see this portion here, negative region, so here the graph is there. In the right side you can see the graph is there, this portion. At pi by 2 there is a hole here, so we have to put this portion also. So this is the portion and this is the graph. It's okay. And later on minus 2, that is it, because negative 1 point something, that the result will be minus 1. So the portion which consists this part, you know the portion where it consists this portion, for this entire portion it attains, for this entire portion it attains minus 2. Why so? Because negative 1 point any number, that will go for minus 2. So this portion is minus 2, and less than minus 1 number will attain for minus 1. So up to this one, pi to 7 pi by 6, the result is pi to 7 pi by 6. Pi is somewhere here and 7 pi here. Pi you have to find whole. Here also at 2 pi there is a whole here, and at 11 pi by 6 this. So this is the graph. Okay, fine. So in this way we can draw gi of 2 sin x. Now the time to draw graph of y equal to gi of x by 2. So you have to draw first of all y equal to x by 2 line graph, and once again y equal to x by 2 line graph. After drawing y equal to x by 2 line, mark the integer points on y axis, as these lines intersects the curve, these lines are intersecting the curve over here at different points, integral points. See, at 1 it intersects at 2, because y equal to x by 2 is there. So at every 2 multiples of integer, multiples means 2, 4, 6, so on, it gives different integers 1, 2, 3, 4 correspondingly, as y equal to, that is y equal to x by 2 line. So that is y equal to x by 2 line. So these points, integer points, and mark these integers where it intersects the curve. Here it's very easy to understand over here. So you have to drop the perpendicular, and from previous dot you have to join like this, you have to join like this, you have to join like this. Okay, so this is the graph of gi of x by 2, this is the graph of gi x by 2. You see the graph is over here. This is the graph y equal to gi of x by 2. Okay, so this portion is y equal to gi of x by 2. Let's say, fine. So in this way we have already took the idea how to draw the transformation for different functions, and we will learn more on this transformation later on for as like some y equal to fraction part of x. So think about how to draw y equal to fraction part of x as. So for y, as you know, for y equal to how to draw fraction part of fx. So we will learn more transformation. Y equal to, you can also think about how to draw the, and we'll take some example also. Y, as in another lecture we will go for y equal to fraction part of fx, y is equal to f of fraction part of fx, and y is equal to, as we haven't studied this one, f of gix. We have studied gi of fx, but we haven't studied f of gix. So we will go for f of gix, as we have already discussed mod of x and f of mod x, and then after. And besides mod on these all functions also, we will discuss in detail later on. Okay, so think how to draw, and we will meet in next lecture. Hope so you all are studying. Okay, fine. Thank you.